Welcome back to the Gem Files. Today we're stepping into the dark. We are opening case number 05 in the vault of broken physics. Now, this isn't your standard look at cosmic phenomena. What we're doing here is a precise, forensic investigation into a boundary where the fundamental rules of reality seem to completely collapse. So prepare yourself. We are about to look at an existential threat to the foundations of science itself.
Can the universe forget? I really want you to sit with that question for a second. Think about this. If you burn a book, modern physics insists the information inside it is never truly lost. In principle, if you collected every atom of ash and every photon of light, quantum mechanics could run the tape backwards and reconstruct every single word. Which brings us to part 1, the eraser crisis, unitarity broken.
You see, that absolute guarantee of recovery, what physicists call unitarity, shatters when that same book falls into a black hole. The universe suddenly faces an erasure crisis. The book crosses the boundary, and we are forced to ask if reality itself is fundamentally broken.
Let's look at the evidence in part 2, the theoretical war zone, and our conflicting testimonies.
For 50 years, the greatest minds in physics have waged an absolute war over this specific boundary. On one side, we have quantum theory, which states categorically that information must be preserved. The book simply cannot be burned out of existence. But on the other side, Einstein's general relativity establishes the event horizon, a causal boundary in spacetime where the library essentially has no exit. These two heavyweight frameworks are completely incompatible here.
And the conflict becomes unavoidable because of Stephen Hawking. Here's exactly what happens. First, matter crosses the event horizon. Second, over immense timescales, the black hole emits Hawking radiation, slowly evaporating its own mass. And third, it vanishes completely. According to Hawking, when a black hole evaporates, it leaves behind nothing but a featureless void. Everything that ever fell inside is seemingly erased.
The horizon doesn't just trap matter, it challenges memory itself. If that radiation is completely random and carries no detailed blueprint of what originally fell in, then the universe has effectively suffered amnesia. This is not a minor puzzle. It is an existential threat to the foundations of science.
So, we clearly need a new way of looking at this. Section 3, the paradigm reframe through general emergence mechanics. General emergence mechanics, or GEM, shifts the paradigm completely. It doesn't offer a magic bullet, but rather a thoughtful reframing of what we're actually losing. It introduces this concept of recoverable coherence. In this framework, information is not just a physical object stored inside matter. It's a structural pattern. A system carries information not because of the atoms it's made of, but because its coherence remains, in principle, recoverable.
Information is recoverable coherence. By shifting to this exact perspective, we stop seeing black holes as monstrous cosmic shredders. Instead, they turn information into a question of recoverability. We move away from a loss of physical matter and toward a crisis of geometry and decoding.
Which leads us to part 4, the admissibility boundary, a geometry of no return.
Under the GEM framework, outside the event horizon, signals and structures remain completely recoverable. But inside? Inside lies an extreme coherence boundary, an admissibility boundary. Outward recovery is quite literally removed from the menu of possible futures. Physics doesn't just turn off, but returning is no longer part of the available geometry. So the question is not where the physical object went. Tracking the physical matter is a dead end. The real question is whether its coherence, its structural blueprint, can still be decoded, even after it has crossed into a geometry of no return.
And that brings us to our final analysis. Section 5. Does the universe forget? Let's open the forensic ledger.
Let's calmly walk through the array of suspects here. The fate of coherence remains an open possibility. Is it hidden right there at the boundary of the horizon? Is it deeply scrambled into that outgoing Hawking radiation? Maybe it's encoded in incredibly subtle quantum correlations we just don't possess the tools to measure yet. Or is it genuinely lost beyond recoverability? The search has not failed because it was foolish. It remains unfinished because the universe has not yet confessed.
Now, case 05 doesn't exist in a vacuum. It connects deeply to the wider vault we've been exploring in these explainers. Just like our investigations into vacuum pressure, cosmic expansion, and dark matter, the black hole information problem ties right into the ultimate structures of reality.
It links these admissibility boundaries to entropy, holography, and the very idea of gravity as a depth geometry. It asks, fundamentally, whether the universe preserves its own history.
This problem isn't proof that physics has collapsed. It's a flashing warning light on the dashboard of our understanding. Quantum theory says information is preserved. General relativity says some regions never return. Hawking radiation forces the conflict. But through the lens of GEM, we see a profound possibility. A black hole may not destroy information. It may hide coherence behind a boundary the outside universe can no longer decode. The universe might not forget, but it might bury memory behind geometry.
I'll leave you with this final thought. Look at the geometry. Look at the boundary. Does a black hole truly erase information, or does it just move coherence beyond the reach of ordinary recovery? Thank you for exploring the vault with me in this explainer.